Okay, this is the final exam review. Question number 1 asks for the molar mass of CH3. So you add up the mass of carbon and 3 hydrogens from the periodic table, and you get a total mass of 16 grams. Question number 2 asks for moles of CH3. So you take the grams and then you convert them to moles. So moles on top, grams on bottom. This mass comes from the periodic table. Number 3 is equal. Number 4 is a mass-to-mass problem, so we're starting with grams of potassium fluoride, and we want to find grams of potassium chloride using the balanced chemical equation that is provided. So it's first grams to moles of potassium fluoride, and then it's moles of potassium fluoride to moles of KCl using the balanced chemical equation, 2/2, and then moles of KCl to grams of KCl. This is the mass of the KCl from the periodic table. Then you multiply everything across the top and divide by the stuff on the bottom, and you should get 46.4 grams. Number 5, this is a limiting reactant problem because they give you the mass of both reactants for aluminum and for iron oxide. So we have to find the mass of iron that's produced by each of those, and the smaller of the two answers will be our limiting reactant. So we take our 35 grams, convert that to moles of aluminum, then we do the moles of aluminum to moles of iron using the coefficients in the balanced chemical equation, and then moles of iron to grams of iron. This is the mass of iron from the periodic table, and we get 72.3 grams of iron. Now we do the same thing for iron oxide. We're going to solve for iron, so we will convert grams of iron oxide to moles, moles of iron oxide to moles of iron using our balanced equation, and then moles of iron to grams of iron. Again, multiply across the top, divide by the stuff on the bottom, and you get 15.9 grams. This is our answer because iron oxide is our limiting reactant, so that is the maximum amount of iron that can be produced given this amount of aluminum and iron oxide. Number 6 is a percent problem, percent composition. So we add up the mass of boron and 3 fluorines from the periodic table. We get 10.8 plus 57, and that gives us 67.8 grams total for the mass of BF3. Then we take the mass of the fluorine, 57, divided by the total mass, 67.8, times 100 to convert it to a percentage, and we get 81.4% fluorine. Number 7 is just a question asking you about Avogadro's number, and that is equal to 6.02 times 10 to the 23rd. Next problems, question number 8. You need to know that 1 mole is equal to 22.4 liters. That's a molar volume of a gas at STP. That information's on the back of your periodic table. And so knowing that, we can take our grams of water, convert them to moles first, then using our balanced equation, do moles of water to moles of oxygen, those coefficients there. And then our last step, instead of going to grams, we're going to go from moles to liters. So 1 mole of any gas is always 22.4 liters. Again, that conversion is on the back of your periodic table. If you forget that the molar volume of a gas is 22.4 liters, then again, multiply across the top, divide by the stuff on the bottom, and you get 28.6 liters. For question number 9, you need to find the chemical formula for calcium carbonate because it just gives you the words, but it doesn't give you the actual formula. So to do that, we go back and we say, okay, calcium is in group 2, so it has a positive 2 charge. Carbonate is a polyatomic ion on the back of your periodic table, and it has a negative 2 charge. And so plus 2 and a negative 2, sum of the charges equals 0. Therefore, your formula is this. Now that we have that information, we can go ahead and solve the problem. We're going to go from grams of calcium carbonate to moles. Okay, this is the mass of calcium carbonate from the periodic table. That's why we had to do this first. Then we go from moles to particles. Okay, remember particles is Avogadro's number. And then we multiply everything across the top, divide by the stuff on the bottom, and we get 5.1 times 10 to the 22 particles. For questions number 10 and 11, for question number 10, Um, Things you need to know is how does temperature affect volume? So that is Charles' law. It's a direct relationship. As one goes up, the other one goes up. Before an experiment, you should ask experts their opinion. And in any experiment, you should be performed at various temperatures if you're trying to see the effect of temperature on volume. So there's some experimental types of questions on your final exam. As for number 11, that question was just answered. The relationship between temperature and volume is a direct one. As one goes up, the other one goes up. For number 12, on a molecular level, what is happening to the average kinetic energy? Kinetic energy is increasing. Okay, for number 13, this is an ideal gas law, I'm sorry, not ideal, a combined gas law problem. So your formula is P1 times V1 over T1 equals P2 V2 over T2. We plug the values in, we're solving for V2, you cross multiply and divide, and you get 3.4 liters. Number 14 is 22.4 liters. And number 15, we need to use the ideal gas law because we're dealing with number of moles of gas. Anytime we have moles, we need to use the ideal gas law. It's the only one that takes that into consideration. So it's our pressure times volume equals our number of moles times our R value. Remember, R is the ideal gas law constant, and T is our temperature in kelvins. So pressure times volume equals number of moles times our ideal gas law constant R times your temperature. And again, R is found on the back of your periodic table, and you choose the one that matches the units of pressure. And this happens to be an ATM, so we choose the R value that's an ATM. And when you solve for T, you get 1,345 Kelvin. As for number 16, there's the answer, increases then decreases. Number 17 is kinetic energy. Number 18, those processes are either endo or exothermic. Study your phase changes. So going from a less orderly state of matter to a more orderly state is going to be an exothermic process. So if going from a less orderly state, like gas to a liquid, solid to a liquid, then you would have to put energy into that. So just think of heating, and that would be an endothermic process. So number 19, since we're going from a gas to a liquid, that is an exothermic process.